So here's where we left off on our handout. So number 8 asks you to put an x in front of any equation that is not linear. In order to really understand what a linear function is, then you need to be able to contrast that with what a linear function is not. So please pause the video and just go through and, what does your gut instinct tell you about each of these equations in A, B, C, D, and E? Okay, so pause this and see what you think. Okay, so if you're back, what I wanted to show you in some of these other slides, and don't try to frantically take notes on any of this because we're going to spend the whole semester talking about different functions and recognizing the different classes and groups of functions. So I just have some examples here that I snipped off the internet just for the purpose of this lesson. All right, so we've got our linear function here, like this would be the line y equals x. This one here, right, I hope you recognize the v as the absolute value. Again, don't panic if you don't, because we're going to get to that. So this would not be considered a linear function. And neither would our quadratic, right? So anything where x is squared, right, would give me a parabola. This is our standard parabola, but we often shift it, right? So something like this, again, we'll be studying this later. So this is not linear. Our cubics, right, anything to a power other than x to the first is not going to be linear. So these get us into our polynomial functions. Anything where x is not to the first power, right? So a square root function, which looks like this, x is to the 1/2 power. That does not produce a linear function, nor does x to any negative power. Okay, so 1 over x is actually x to the negative first. X to the negative second is the same as 1 over x squared. So these are not linear functions. On this side, I included a few others. Some of these are the same ones on this last one. We've got our exponential function, our logarithmic function, some of our trig functions, right? Obviously, things in this form are not linear. So going back to this example, x to the 1/2, right? We can't have that. This would be a shift on that square root function, which is not linear. And if I distribute through parentheses, over here, I get x squared plus 2x, right, which would be a parabola, equals y. That would be a parabola. That would not be linear. Probably the one you recognized the best, because this is in the form of the standard equation of a line that I gave you the other day with the a, b, and c, right? So this would be yes. It does say to find the slope and y-intercept. So you would need to do some manipulation here to get this in the y equals mx plus b form, adding 10 to the other side, subtracting 3x from the other side. And then when I go to divide by 7, I need to divide each term on the other side by 7. Okay, because I can't divide into one term of a sum without dividing into both. If you don't believe me on that, try this problem. Try the problem 10 plus 8 divided by 2, right? Because I'd be dividing this whole other side by 7. You will see that if I try to just divide one of these by 2, because obviously the answer I should get here is 9, the only way I'm going to get 9 is if I divide both the 10 and the 8 by 2. Okay, so this is called trying a simpler example to prove that something, or to verify something is true in a harder example. So in this case, my slope would be -3/7. And my y-intercept would be 7, or 10 over 7. I'm sorry. So that would be the y-intercept, which occurs when x is 0. So I would need to list it like this. This would be the 0.010 over 7. Okay, so the y-intercept occurs when x is 0. So same thing here. I could distribute this, right, and then rearrange that into y equals mx plus b form. And this problem, in order to simplify this a little bit, let me point out that the fact that x is on top shows that it's linear, right? If I had something like this, where I had like the x down, if it was the other way around, if it was the reciprocal and x was in the denominator, right, that would not be a linear function. Okay, but I can take both of these terms and divide by 3, right? So that's really a 1x, right? So I would have a 1/3 x plus a 4/3 x. So again, please finish this on your own, and we will go over these answers when you come to class. Now, the classwork that I'm asking you to do for this section is number 9 and number 10. Now, I want you to try number 9. Now, I didn't teach you this, right? Try it, because some of you will remember this from high school. All right, if you can do number 9, great. Don't watch the next video. If you struggle with number 9, and probably most of you will, I have a video where I talk you through an exercise to help you discover how to write the equation of a line perpendicular to another. And then number 10, most students do pretty well with number 10 with minimal instruction. Okay, if you're having any trouble with number 10, then please go back to the answer or the problem at the bottom of the first page of these notes, where we are graphing vertical and horizontal lines.